Yeah. Yeah, very warm welcome everyone to this seminar series. For today, we have Valeriya Chasova from Utrecht University. She will present a paper on somebody or more people who worked on relativity, on special and general theory of relativity. It's a very provocative title. Who is the author of Special and General Relativity? And of course, we want to hear from her the answer to this provocative question. Thank you very much, Valeria. I leave it to you.
Thank you very much, Sylvia, and everybody for giving this opportunity. And as the question is a bit provocative, I will now explain why, but I don't promise an answer. Sorry, but I will try to advance. I will try to show which answers are available and how can we adjudicate between them, or at least which tools we can use to elaborate more answers if we are not satisfied with these ones. So if we look at the question, who is the author of special and general relativity, then this question for someone who is familiar with philosophy of language resembles very much to a use of a definite description. So a definite description is when you use a definite article there plus some property which your object is supposed to satisfy. And in this question, there is precisely such a property. So you are supposed to speak about the person who is the author of this series. And it might seem like you have just one person who must satisfy this property. This is as if you were asking who is the person over there while pointing to a particular person. This person would be a specific person and it would be a unique person. But in fact, the definite descriptions are not always singling a unique particular person, especially if you have indexicals like over there. If you want to make this precise, it turns out that you can make it precise in different ways and therefore single out different persons. If you ask who is the person over there at some point of time or some point in space, you might be pointing to one direction at one moment and to another direction in another moment, and in this way you might single different persons. So sometimes the same question might be not about a unique person, but about several ones. And sometimes it can even be about no person at all, like in Russell's question, who is the present king of France? Both now and 121 years ago, there was already no king of France officially. So that question singles out no person. And returning to our question, who's the author of special general relativity, it might also be, despite appearances, that it might single one person, it might single several persons, but it might also single out no particular person. And getting a bit more precise, so if you go to the website of the Cosmos Network, you'll see here there an announcement of my talk with this very question, who's the author of special and general relativity. And this announcement happens to be illustrated with a picture of Einstein. It was not myself who put this picture, it was someone from the network. And I don't say that you must take this seriously, but still there is something in this fact. So someone put Einstein to illustrate my question as if Einstein was this single person who is the author of special general relativity. And this is, of course, an option, but it's not an only option, as you now know from my previous discussion of definite descriptions. So here are further options you have for special relativity in particular. You might have, instead of, or in addition to Einstein, a combination of Lorentz here at the top left and Poincaré top bottom left. And for general relativity, you might have, instead of or in addition to Einstein, for instance, Hilbert. And there are further options. So besides this multiplicity of persons, there are also options where nobody is the author. For instance, if you like a kind of counterfactual history, then you might say that, okay, perhaps some one of these persons have formulated some relativity, but if there were no such persons, relativity would be formulated by someone else, and so no particular person is really the author of this series. Or you might also believe that series are like Platonic objects and they are just discovered and not formulated. So there is no author in the sense of creator. There is just someone who discovered, and again, then there will be no author in this proper sense. So there are various options, and I will concentrate on just the previous ones. So the ones where we have a choice between Einstein, Poincaré, Lorentz, and Hilbert. Uh, so. Um, so here are the options, and why do I concentrate on these particular options? Well, because because I was not the first to ask this, and I am actually reacting to previous persons who were envisaging precisely these options. So I sent to the organizers the annotation of the abstract of my talk, and there I promised to address in particular these four texts by Darigol 2005 and Gengras 2008 and the Korean Station 1997 and Zauer 2005. So these were the texts I wanted to address, and they present different options for different series. I also, a few days ago, I advertised my talk by sending the announcement to some lists, and I was contacted by Jean-Marc Genoux, who reminded me of his book of 2024 and Gengras review of that book. So I thought I can also say a word about this. So that will be the text I will be talking about, but we will not get there immediately because I want to still make some preliminary remarks. So when you see this multiplicity of choices and authors who are making different choices, firstly you might ask, why should we bother with this question at all? And I have several answers. So first, if we are not obliged, we actually must not always trust what is all believed. Instead, we must always verify. If we are philosophers, then we are there to doubt and to check. If we are historians, we are there to see what are the real facts. We cannot just start with like the usual common opinion that the creator of our series was Einstein or whoever, and finish there. We must make some investigation. And this, of course, applies, but this is a general methodological principle which applies also beyond much well beyond the debate I'm speaking about. If we speak about this particular debate, we must study just because the question is always there. It's already not taken for granted that there's a particular person who is the author of all series. There are already debates, so we must, if our interests are somewhere around there, then we must address this question and consider it as well. And one counter argument to saying that we should take seriously this question of authorship is that some people think that the debate is already solved, and some people think that the arguments are serious only on one side of the debate, but not on another. In particular, for instance, so Gengras makes a review of Genoux, and Genoux replies to that review, and he replies in a way by saying that Gengras has made a number of errors, and so he's not making well his job, and so on. So his reply is quite heated, and Gengras could say, "Oh, why are you bothering with Genoux at all? If he's making a heated reply, maybe we should not consider this seriously." But I think we should actually distinguish emotions from arguments. And even if someone is emotional, it might still be the case that he's making some profound arguments. So we should not just be diverted by emotions. We should look at the arguments. And if we do this, we see that there are enough interesting arguments at either side of the debate. So those who like Einstein, those who like Poincaré, and so on and so forth. And finally, even if you are not, if you're not interested in the authorship of this particular theory, but perhaps you're interested in the authorship of another theory or some literary work, or maybe you are disputing authorship of some idea with another scholar, whatever. So we can make general models which apply to other authorship debates or similar debates by taking these debates as our starting point. So by all these reasons, I think the topic is worth being discussed. So if we are to discuss this topic, we would like probably to have some common structure so that we can like put the structure as a background. I wanted to put a picture of some tree here, and different people would be at different branches. So we would like some common structure behind them all, and then for me it would remain to just position different people with respect to this common ground and say they agree on this thing, but they disagree on this small detail. That's what makes a difference. But actually, there is not much common structure, and this is also a difficulty of the debate. You might have thought that the common thing everybody agrees on are, for instance, crucial texts, their dates, their content, and the belonging of this content to a particular theory. But actually, all these things are contestable points. But still, so that we have something to start with, I will tell just very briefly what are the crucial texts and the usual chronology that they are assigned. So for special relativity, and I'm not telling you all the prehistory because if you go back into history and you always find some precursors, and even if you don't find it, it's maybe just because you don't know about them, but they are still there. So I just tell you the last few years. So there was a text by Lawrence, which was in the Dutch, but it was translated at the same time in English. So the electromagnetic phenomena in a system with any velocity smaller than that of light. So in this text, he introduced, he improved actually his previous transformations, and Poincaré was unhappy with the previous transformation, but he was more happy with improved transformation. So he made another text which was improving these Lorentz transformations even more. And the results that he got are the Lorentz transformations as we know them. So even if they are called the Lorentz transformations, they came from Lorentz, but they were improved by Poincaré, and it is this improved form which we know under the name of the Lorentz transformation, and which is the kind of transformations which are used in special relativity to go from one frame of reference to another, which is boosted with respect to the first. So Poincaré made his text in the fall. It appeared in two forms. Both were in French, without English translation at that time, and they were called on the dynamics of the electron. And one was very short. It was published in 1905, and another was long, and it was published in the following year. And in between these two things, the short and the long version, Einstein made his own text, which was not relying explicitly neither on Lorentz nor on Poincaré, and which was written in German, and it was called on the electrodynamics of moving bodies. And he introduced directly the same Lorentz transformations, so the final form, the one which Lorentz and Poincaré were making together, so to say, in different steps. He introduced the final result immediately. Without references to them. So that's the usual chronology and the usual results and how they usually told. So Einstein's paper was in between the Poincaré's short and long papers. So that's for special relativity, and of course the one way in which the debate becomes non-trivial is when you start to doubt the chronology or whether the Lorentz transformations are the main element of special relativity. And similarly for general relativity. So we have one paper by Hilbert, which was both were in German. So one Hilbert's is the Foundations of Physics, the first communication, and the second is Einstein's The Field Equation of Gravitation. So again, Hilbert submits his paper in 1915, but publishes in 1916, and Einstein submits and publishes in between these two dates. And they both contain or seem to contain, this is the final outcome, does contain the same result, which are the field equations, which we now know as Einstein's field equation, but they are also in Hilbert's text. And so again, you have, you see how the debate arises. So that was like around more or less half of the talk, but maybe the least half. Now we go to the second, which is precisely what were these persons saying about different possible authors and how which arguments they were advancing, how they were proceeding. So let's go into the details of various persons' positions, and we start with Gingras, with special relativity, and inside it with Gingras. I took his 2008 text, which is very long, around 40 pages, and it makes the point that the author of special relativity is Einstein and not Poincaré. Well, you might ask what of Lorentz. Well, he does not want to discuss Lorentz very much because he actually the kind of approach he's using is not very particularly favorable to discussing Lorentz because it singles out well Einstein from Poincaré, but it wouldn't single out very well Einstein from Lorentz, and that's apparently the reason why he does not take. So he recognizes that, okay, Lorentz played some role, but let me concentrate on Einstein versus Poincaré, and then you will see that Einstein is the author and Poincaré is not. Okay, but he uses Lorentz to argue also against Poincaré. So that's the thesis, and how does he arrive to his thesis? So he considers a period roughly a century before his work. So he has different period for the first and the second part of his analysis, but essentially the point is that he is considering from the period around the Einstein and Poincaré papers, which contains the final form of the Lorentz transformation. So from that period till something like his own time. And he has a two-step reasoning. So at the first point, he is making a citation analysis and a co-citation analysis and a analysis of networks as it appears from citations. And in the second part, he analyzes the quotes. So citation is when you mention a particular text, and quote is when you give a precise you give a precise phrase, and this phrase is saying this person made this achievement and so on. So the quotes are about content, and citation rights are about mentions of text without going into the content. So this is here I'm showing how the first part of Gingras' analysis looks like. So he provides with his disciples a number of schemes, and I put actually two schemes here. So the first, which is in two parts, it's the comparison of citation rates of Einstein's paper comparing the Lorentz transformations and containing the Lorentz transformations, and Poincaré's long and short and long papers containing the same Lorentz transformations. So you see that in black is Einstein, in white is Poincaré, and you see that Einstein is cited quite widely from the outside, and then there is a period where nobody is cited, but then from the 50s, Einstein starts to be cited very much again, and it increases, and also Poincaré starts to be cited at some point, that it also increases, but not as much as Einstein. So you see the the preference of Einstein over Poincaré in citations, and you see that Poincaré starts to rise after the 50s. So that's the main things for them. And another is a co-citation network. So when two persons are cited in the same paper, and you see in the red rectangular shapes, I highlighted Einstein and Lorentz, and you see that Poincaré is not there. And this starts to make a point that Einstein and Lorentz are physicists and Poincaré is not, because this is a co-citation network of physicists. Okay, so he has established these two facts, that how the citation grows differently, and that Einstein is a physicist while Poincaré is a mathematician, and he also says they come from different countries, okay, and different linguistic areas. And then he uses quotes to explain why you have seen this difference in citations and difference in networks. And his explanation, given the analysis of quotes, is the following. There is a tendency to propel Poincaré's contribution into special relativity. And this tendency is, in the 20s, it starts with Klein. In the 50s, it is particularly put forward by Whittaker. And in the late years, it is triggered by commemorations. Klein is a mathematician. Whittaker is a mathematician who likes general gravitational theory, which is unlike general relativity. And commemorating persons are in particular the French. And so Gingras makes a conclusion that the fact that Poincaré starts to be presented from the 50s, especially as a creator of relativity, or even the creator of special relativity, this is just due to the interest of mathematicians, adversaries of general relativity, of Einstein's style, and the French people. So, and he say, don't believe the mathematicians, the French people, the persons who are like commemorating 100 years after the fact. Believe instead to early physicists, the ones who were there around the Einstein's time and who started to cite Einstein immediately and were not citing Poincaré. So this shows that the real author is Einstein. So, we can say, yeah, okay, we understand your advice. Avoid late mathematicians, try to early physicists and their preference. Okay, but why should we believe early physicists? Okay, why? And he thinks that he's closing the debate because he's reacting to a text by Darigolle of 2004. And Darigolle in 2004, he is not going into any chronology. He just says, well, let's compare Einstein and Poincaré. They are quite similar. Gingras says, oh, you are looking 100 years after the fact. Let's go to the physicists which were 100 years earlier, and so on. So he has his analysis of Gingras is motivated by his willing to reply to Darigolle, who is looking from a contemporary perspective to something which was happening 100 years ago. But actually, Darigolle is besides this 2004 text to which Gingras is replying, Darigolle has another text which is 2005, and in this text, Darigolle is going into history quite like Gingras was advising, but he does this even more because he actually goes into the century which was not after but before the Einstein and Poincaré papers, and he claims a difference, well, a somewhat different thing from Gingras by using this analysis, because his claim turns out to be that the authors of special relativity relativity. Okay, maybe Einstein is one of the authors, but Poincaré is also to some extent an author. Lorentz is also to some extent an author, and maybe there are some more persons. Okay, so Daigo's text is avoiding the approach by Gingras because he looks at historical persons, and he's also he's shown that with the same kind of historical approach you might get a different conclusion. So what but at the same time Daigo's text allows to motivate Gingras, because Gingras says look at early physicists, and I am asking why, and Daigo would explain why, because he what he wants to say is that if we are to look at some physicists at all, it is because they were introducing some components which afterwards became known as special relativity. So as I said, Daigol makes a history of how special relativity was formed by looking into which person introduced which components, like transformations, like the postulate that the speed of light is a constant, like the relativity postulate in one understanding or another, and so on. So he says this person introduced this, that person introduced that, and so on. Okay, and that's how he goes, except that he is not only interested in special relativity, he's also interested in classical electrodynamics, because he thinks that special relativity grew from classical electrodynamics. So he's good at showing that different persons have contributed to different theories in different extents, and therefore can be the authors also to different extents. What he is not doing is that, firstly, he does not have the notion of some component belonging to some theory, because he says that each author develops his own theory. So that's a bit complicated to use his analysis directly to the question to answer the question who was the author of a theory. But and moreover, he does not tell whose components contributed into classical electromagnetism and whose contributed into special relativity. So we to get an answer from his article, we need to a bit work by ourselves. So I cannot say that his like decision is already there for us to be taken. But he presents a kind of approach. He presents a number of facts, and if we use these facts, and if we distinguish the different components that different people were introducing, and put some of them, and identify some of them as belonging to special relativity, then we can infer that Einstein, Poincaré, and Lorentz, and perhaps other persons are authors of the same theory, but to different extents, because some introduced more components, some introduced less, and so on. Okay, so that was the main debate as far as I am presenting this. And so if we want to compare the two, we see that they have some difference about who is the author. But probably, but at least they agree, both of them agree that Einstein was the author, and then they disagree about whether Poincaré was also the author or not. Okay, they use a completely different historical periods. So, sorry, I have some works. They use different historical periods. Gingras looks at the 1st century and Rigol to the previous century. And they also differ in their ways to proceed, because citation is completely it's completely unrelated to content. Analysis of quotes is somewhat related, but Rigol's method of analyzing the components is directly related to content. So they have differences, but these are but the first two are less differences than they might seem, because the fact that Gingras says that only Einstein is the author might be related to him not considering the notion of author to be the notion which comes in degrees. If he was thinking that he could attribute some degrees of authorship to other persons, then he could attribute it to Lawrence and so on, and maybe even to Poincaré. I also think that if Gingras applied his method to the previous century, the one that Rigol was looking to, then I think by simply using the citations, he would also find the previous works of Lawrence and Poincaré, who was moving towards special relativity and who was referring to each other. And the picture that he is providing us is, to some extent, an artifact of him looking at the too late period, which is after the Einstein and Poincaré papers. But the real difference is that Gingras is looking from the outside by using citations, and Daigo is looking from inside by analyzing components. It's like a difference in psychology between behaviorism, which is a position according to which your head is a black box and we only see what goes in and what goes out, but we do not see what is going inside. And so that's behaviorism. And cognitive psychology thinks that we should analyze what is going on in the head and we can use empathy or whatever. So the difference between Gingras and Rigol is of that kind. It's between like signs of what is going on versus what is really going on. Okay, so I promised to say a few words about Genoux. So Genoux wrote a book, Gingras wrote a review, and Genoux replied to this review. In the book, Genoux was arguing in favor of Poincaré. As the author, so Gingras says it's Einstein who is the author, and Genoux replies, no, it's Poincaré. And as you know, and Gingras in his review, he's essentially making the same points as he was making in his 2008 articles, but now instead of Rigol, he criticizes Genoux, and Genoux does something else. So he concentrates on just this crucial year of 1905 when the Einstein and Poincaré papers were written. So he does not have any extended history like for 1 century, but he does concentrate also as Rigol on who introduced which components, who introduced the Lorentz transformations, and so on. And his main way to go is that he mentions a few letters which were uncovered by another person previously, but so his crucial argument is the chronology around these letters. So he takes a bunch of letters between Poincaré and Lorentz, and he shows, according to him, he's showing that Poincaré had all the main results of his short and long papers already in the letters, and that the letters were written before Einstein, and even the long paper of Poincaré was written before Einstein's paper. So he uses an archival material to argue for a different chronology with the effect that Poincaré was the first to introduce all the main things which are associated with Einstein, and therefore it's Poincaré who is the author and not Einstein. And again, we see the main differences between Gingras, who is looking at citations and so on, and Genoux, who is looking at the content. But now the extra dimension is that Gingras, he's saying something like, you should not make a conclusion yourself. You should trust to someone else, like early physicists who are making the conclusion. And Genoux says something like, no, it's me who is making a conclusion. I have the right to this. I have analyzed everything. So these are different ways to address the question. And for Genoux, the main remaining question, if Poincaré was the author of special relativity, the main question remains why Poincaré has never claimed the authorship of special relativity. And his answer is that he was making a different kind of theory than Einstein because it was like dynamical and Einstein's was kinematical. But I think there's another way of answering Genoux' question. So why Poincaré never claimed relativity, supposing that the authorship of special relativity, supposing he was the real author, he discovered everything earlier than Einstein. So why he was never claiming that he is the author? it seems to be one possibility is that Poincaré was too modest because in his letters he says something like to Lawrence, he says, "Oh, your theory is great. There is just some small problem. I found how to solve it, and now my results are in perfect agreement with yours." And but so he presents everything like he has solved a small problem with Lawrence theory, while actually he is making quite a great advancement, and it must be checked. But my my hypothesis is that probably he was diminishing the significance of his own results. If it's true, then you might also find this in other examples in Poincaré's other results where his modesty is manifested. But the last point I wanted to say on this part, which concerns special relativity, is that Gingras' analysis is interesting because we can make it one level up. Because he's saying about some people like the French who are commemorating the creation of special relativity, and they say about a person from their country, Poincaré, that Poincaré must be an author because he's also French and so on. So Gingras is analyzing, is approaching the other person's opinions with his sociological and quantitative method, but we could also apply the same method to the protagonists of my talk, like Gingras, Genoux, and so on, because, for instance, Genoux is a person from France, and we could say with Gingras, so of course Genoux is in favor of Poincaré because Poincaré was from France and Genoux is also from France. That's the real explanation. So Gingras' method is good because because it applies also not only to some past persons who are commemorating Poincaré, but also to these persons like Genoux, for instance. But I would highlight that even if Gingras' method applies to the protagonists of my talk, the fact that someone is a French like Poincaré does not explain, well, it explains that Poincaré must be the author only because he's from France. So I mean, it's sure that if Genoux is from France and Poincaré is from France, then Genoux is more likely to argue that Poincaré is the author of special relativity. But it does not mean that his only argument, that he does not have any good arguments to argue that Poincaré is the author. He is just like he has a tendency to argue that Poincaré is the author, but he does not stop there. He doesn't say it's a person from my country, therefore it's the author. He is saying, look, I look to these letters, they were written earlier, they contain all the same results, therefore Poincaré was the author. So the fact that that sociological factors are present and it is not the full explanation of why some person is the author or is not the author. Okay, so now we move to the last part of the talk. So it's a bit more than 40 minutes, but we are going towards the end. What of when we go from special to general relativity? Now here's an important difference because special relativity is in a sense unlike other usual theories, including general relativity. So special relativity is somewhat special because it does not have its own dynamics. So what it has is these Lorentz transformations, which allow you to pass from one reference frame to another, which is boosted with respect to the first. It might have other components like the constancy of the speed of light and so on, but it is not describing how some kind of system evolves even in a single reference frame. By contrast to general relativity, who tells you how a planet is going around the sun or whatever. Okay, and so special relativity is the kind of background which is compatible with electromagnetic dynamics, but also with other gauge interactions which were developed very like half a century after Einstein and Poincaré. But general relativity has a precise dynamics, gravitational one. So in special relativity, there can be a controversy about which components belong to it, which are essential to it, and which are not. But in general relativity, it seems like the main component of which is like essential for this theory are the equations which we know as Einstein's equations. So at least it seems like there is not so much controversy about the content, but we will see that there is one, actually. So again, I was not telling you in detail about Genou's book. I was going to Gengral's review and Genou's reply, and here also I will not tell you about the previous view in detail. I will go to the two articles I was promising to speak about and speak about them in more detail. But still, just very briefly, what the previous view was to which Koren and Stachel were replying. So apparently, the previous view was something like that. The main component of general relativity is field equations. These field equations feature in two texts. One is Hilbert's, another is Einstein's. But even though Hilbert's text was published after Einstein's, Hilbert's text was submitted before Einstein's. And since equations are contained in both texts, but Hilbert's text was submitted first, therefore Hilbert is the author of field equation, and therefore he is the author of general relativity. So this is the previous view. And Corey and Stachel object to this view by providing an extra evidence, which is an archival evidence. So here you see a page which they found in some archive, and which this page is the first page of the proofs of Hilbert's article. So you make an article and then it is printed in form of the proofs, and you can correct some errors, and then it goes again to print, and you get the final version. So this is the like intermediate version of the article, so to say. And we see here the stamp of 6 December 1915. So this proof is somewhere, so it's after Einstein published his article and before Hilbert published his article. And the most important thing is that in these proofs, there are still no field equations, which means that field equations, normally they appeared after the 6th of December in Hilbert's text. But by that time, Einstein's text was already published, and this text did contain equations. So now we have the other way around. Beforehand, we thought that first there were equations in Hilbert's text, and afterwards in Einstein's, and therefore Hilbert was the author, and Einstein was just repeating what was already there. And now we have the other way around. So first Einstein published his paper with equations, then there are Hilbert's proofs which do not contain the equations, and afterwards, only afterwards, Hilbert publishes his text which does contain the equations. So now Einstein becomes the author of equation and therefore of general relativity instead of Hilbert. And Zauer wants to object to that, and he does this in two ways. So firstly, he says, well, this is the first page. And there are sheets of paper, okay? So on one side you have the first page, on the reverse side you have the second page, then you have the following sheet of paper where there are pages 3 and 4, and then you have 5 and 6, and then you have 7 and 8, and some more. And you see that in the 7 and 8, the upper 1/3 is missing. Because to the left you see the full sheet of paper from both sides, and to the right you see the following sheet of paper with some part missing. And the first thing Zauer is asking, so he has a 2005 article which was then repeated in the 2007 book, but he just added some notes with references to other things in the same book where it was reprinted in 2007, but it's essentially the same text. Okay, so Zauer, the first thing he is checking is, could the equations be contained already in this missing part of the proofs, which was of course after Einstein's article, but not very, just 4 days after Einstein's article. So perhaps, okay, Einstein published his field equations, but also Hilbert maybe had these equations in the proofs already, and then he would be quite close to be still considered as a second author of independent, maybe author of general relativity. So Zauer checks this, and because you see equations are numbered, so you can infer that some equation is missing, and then in the following part of the text there is a reference to this missing, well, to the what could have been contained in the missing piece, so you can reconstruct a bit. So he makes such a reconstruction, but it turns out that equations most probably were not there. So the missing part is a possibility to argue that equations were there, but according to his reconstructions, equations were not there. Okay, so what he does, the second and final solution is, okay, he says, okay, suppose that there were no equations at all, even at the submission point. Not only in the proofs, but even when by the time he was submitting, there were no equations in Hilbert's text, and there were equations in Einstein's text. Then you would think that, okay, Einstein is the author if equations are the main component, the crucial component of general relativity, and they were present only in Einstein's text and not in Hilbert's, even from the beginning, then Einstein is the author and Hilbert is not. But, says Tillman-Zauer, why are you sure that the field equations are the main component of the general relativity? Maybe the main component is the variational principle. And the variational principle, what is this? It is when you vary, you impose a symmetry on an action, you vary the action with respect to that by some transformation, and the fact that this transformation is supposed to be a symmetry, it amounts to a condition which is equivalent to the field equations. Okay, so Zauer says, okay, there were no equations, but there was a variational principle which was equivalent to the equations, and everybody agrees that Hilbert is the promoter of variational principles, that he had a variational principle from the outset, and so on and so forth. And he says, okay, if the variational principle is equivalent to equations, and if we agree that Hilbert had the variational principle from the outset, then he had a result which is equivalent to Einstein's, and therefore he is the author of special general relativity, not less than Einstein. And of course, the whole question hinges on whether the thing which is equivalent to equations is really the same as equations or not, because to get equations from the variational principle, you need to make some reasoning and so on. And this is like in a philosophy of knowledge, you have, when a person knows that knows something but does not know that this something is identical to another thing, does he know the other thing or not? It's the same kind of question. So I'm going to the conclusion, just a couple of things to add before this. So what else can we say when we abstract away from particular points of view of particular researchers that I presented? I think one question which needs to be asked and answered is when does the question of authorship becomes the question of priority? Because you see, the question of priority is who was first to introduce a thing, and the question of authorship is who was the author. And sometimes the person who is the first to introduce something becomes the author, but sometimes the question is not about who was the first. So I would ask, when is the authorship questions becomes the priority question? And I would answer that we speak about priority when the content is the same and the only question is about who introduced this content first. But as soon as we have a disagreement about which content is essential to a theory, then we are no longer asking the question of priority. We are first asking the question of what belongs to this theory and what does not. Okay, and the second question, which is also worth asking and on which I don't have a definite answer yet, but which is clearly there, it's what's the role of objectivity? Because when Gingras says that you must not believe late mathematicians, you must rely on early physicists, surely he wants to say that the late mathematicians, the French people and so on, they are biased, and the early physicists, they are not. But so he implicitly he uncovers this question of what is the objective way of answering the question of authorship, but he is not providing a good outcome, a good way to answer this question of what is the objective means, because he is saying that belief to early physicists, it is no guarantee that the early physicists are not biased, that they know everything, that they know Poincaré's letters to Lorentz and whatever. Okay, so objectivity is clearly somewhere on the background, but it can still be reflected about how it can be best incorporated into the debate. So I conclude by just summarizing what I've told. So there can be one, several, or no authors of a particular theory. The question of authorship of special relativity, general relativity, or some theory in general is worth being discussed. The common core could have been the crucial texts, the chronology, and the content of this text. It is a common core in the sense that everybody speaks about that. It is not a common core in the sense that actually many people disagree about the details of this. And when we go into particular approaches, we saw that there is a kind of external approach of genre, which is using external indications like citations, which is relying on social factors, and which is observing them from the outside. And there is another approach like Dreygo's and Genou's, which is looks at internal motivations, internal derivations on physical motivations, and which says, which affirms that the person who is making the analysis has the right to decide who is the author, and not just need to rely on someone else to tell who is the author. And we saw that the archival sources play much role, because the proofs of the Hilbert's first communications, or the letters of Poincaré to Lawrence, these are kind of things which might change the answer to the debate. And we also see that how special relativity is defined, with equations are the crucial thing for general relativity. These are kinds of things which also influence the debate. So here are the primary sources which you know, including the proofs of the Hilbert's note, and these are the secondary source, the secondary literature. So thank you very much.
Okay, so many thanks, Valeria, for your presentation. It was a long but worth examination of the arguments from these historians of science, such as Darigaud. Now I open the Q&A, of course, for the participants. So if you want to ask questions to our speaker, other questions or remarks? No, okay, so then I will do that. I mean, it seems to me that it's clear that we ask about the authorship of a piece that is, oh, Govan was there. Okay, I will ask first the question, then leave it to Govan. So it's clear that we talk about authorship when we refer to papers, for example, and to books and so on. I mean, at least as an historian of science, I would say that I would never ask the question who is the author of a scientific theory, precisely because a scientific theory, per definition, is a complex process, that takes time. So let's think about the genesis of quantum mechanics. I mean, it took ages, okay, to reach at least the first formulations and accounts I mean, 100 years ago. So I think that, I mean, I just wanted to point out that perhaps, I don't know what to think, Valeria, that rather than talking about authorship with respect to a scientific theory, so special relativity, general relativity, quantum mechanics, and so on, one can rightly pose the question of the authorship of a paper, eventually, or a book, or a formalism, That's something that should be in place. For the case of Einstein's equation, I mean, we do have tons of literature on Grossman, for example, and Einstein, the correspondence, and the tantalizing effort to find the correct formalism for GR. In that case, I mean, we don't say that, I mean, we call the fields equations Einstein's field equations and not Grossman's field equations. So, and there must be a reason for that. And this reason is found, by analyzing the correspondence they had and the turnabouts, thinking about how to use the Levi-Civita connection and all the formalism that, is at the ground of the theory. So I don't know. What do you think about these reflections?
Uh, yes, so you have apparently you have a vision of a theory which is like something complicated consisting of many elements, and these components that I was saying, and these components are contributed by different people. So there is a kind of collective work, and after many time, the theory is born, but it was born been born all along. Yeah, this is a kind of image which we might have with special relativity, which we should have with quantum mechanics, which we have with gauge theories of the second half of the 20th century. But this is a modern look, which is motivated by the fact that theories become more complicated, and more people start to be physicists and so on. This was less the case for Newton, probably. This was also, we also have Maxwell's equations, which are Maxwell's, whatever we want, not of 100 persons. And again, this is also, we also have Schrodinger's equation. And this is, so in part, this is the evolution of physics. So theories go from less complicated to more. Physical activity goes from that of separate persons to that of many persons who start to interact. Okay, so when we go back to history, I think the question of authorship makes more of a single authorship makes more sense, because there were less persons and there were less results which were needed for you to have a theory. So that's one thing, and another is again what I was mentioning when I speak about general relativity. So are we sure? Okay, there are many elements in this theory, but can we say that the crucial elements is equations for most of the theories, and maybe Lorentz transformations for special relativity? If we are sure that there is this particular component, then there can be just one person who introduces this particular component. And even if we agree that there are also other elements who were introduced by other persons, they are not as essential for us to tell that these persons are the authors. Okay, they are the helpers, but they are not the authors. So I don't know how much this applies to your points.
Well, partially, yeah. Probably we disagree on a few things, but this is normal. I mean, it's intellectual exchange. Though, yeah. I mean, when I conclude, uh, I mean, I think that the one who explicitly talks about postulates of the theory in 1905 is Einstein. And so there's no doubt that he is the author of the paper that he publishes, also of a series of papers that he publishes in 1905, also the paper that got him to the Nobel Prize for the photoelectric effect. So I think that there's no doubt about saying that not the authorship, but um, I would say the understanding of the turning point of those two postulates, together with Lorentz transformations, that could solve the asymmetry emerging in the theory of, I mean, in Maxwell's theory. So that was something that was Einstein's idea and not someone else. I'm sure about it, but not just I myself. I mean, it's something that is written. I mean, it's over there. I mean, if you read Einstein's paper, he's aware of what he's doing. He's aware that it's a new theory. He's aware that it's changing the way of thinking about motion, rest, the ether, and so on. So I think that one can, of course, discuss about this thing about the authorship. It's interesting, but not with respect maybe a theory, a scientific theory, because as I said, I see it as a collective result. And I also disagree that if we go back to the past, there is just one single scientist that can be recognized, as the genius, setting up a theory. I don't know. We will continue the discussion, but then I want to leave it to Govan because he will have wanted to ask
Yeah,
some.
but thank you so much for the talk, and thank you. But you already, by your discussion, answered part of my question. I ask myself often why this question of authorship uh, is especially debated with regard to general relativity and special relativity, but not with other theories like quantum mechanics. No, I don't have the feeling that uh, people care about who is is there one single author of quantum mechanics, or even if you go back to the past, um, yeah, maybe Newton is the exception rather than the rule, but you have a lot of different theories that we don't have this need to find one author and to solve the question of authorship. And why is that so special with relativity and Einstein case?
Uh, I don't know, it's clearly the case that some cases are more controversial than others. Um, I can believe Jean's explanation that to some extent is because the French are like Poincaré. But mm, I'm not sure why this is heated, but I think in the cases where it's not heated, it's probably we are not there yet. I mean, it's with when physics becomes like a job of more and more persons, just simply the probability increases that one person discovers something which another person has also discovered, but we know about the second person, we don't know about the first. But if we dig more into history and into a particular case, we will surely find some more coincidences, and then the question of authorship will arise. Yeah, if we start thinking like about gauge theory, theories of the 20th second half of the 20th century, there is a book by Lachlan or Rafferty who was collecting the early texts of gauge leading to the creation of gauge theory, and there are several texts with similar results. And the reason why the question of authorship did not arise at the time and it arose later is because some authors did quite the same thing, but not exactly. Some person did the same thing, but it was in the PhD thesis, and another published this in a good journal. Some person like Uchiyama, he heard about the Young and Mills. So Young and Mills introduced you probably know the non-abelian. Just to tell for everybody, yeah. So he introduced the non-abelian version of gauge theory, which was very fruitful afterwards, and it was in 1954. And Uchiyama heard this result, and he thought, "Oh, it's terrible because they introduced the same thing as I was doing. So no, it's not worse that I'm doing the same thing because they were already the first." And then after a couple of years, he realized that he was doing a different thing because he was using group theory, and they were not using group theory; they were just using the consequences of it. So yeah, he could have came into the same moment and say, "Look, I am the author of the same thing as you are doing, but even better." But he didn't because he was unsure about himself, because he misunderstood he was emotional author. Yeah, so actually there are more debates when we start digging. And I also wanted to tell more about general relativity because in special relativity, apparently, it seems like Gingras writes that the debate arose later. So by the time of Einstein and Poincaré, there was no such debate. But as to general relativity, there was a debate already around the time of Einstein and Hilbert. So around 1915, firstly, in the Coherence Nature article, there is yeah, so in this article already they are telling that there was an exchange of letters between Einstein and Hilbert, where Einstein was like disappointed by something, and then he said, okay, we should not be against each other. And apparently he was precisely disappointed by the fact that Hilbert included his equations into Hilbert's own work, so Einstein's equations into Hilbert's work, and then he said, okay, I understand that these were not your equations. And even Klein, who I was mentioning with respect to the first debate, he was actually also important in the second debate, because Klein writes in his collected papers of 1921, so just a few years after the creation of general relativity, he writes that he adds a note to say that I think that Hilbert and Einstein are not should not be considered in competition about the authorship, because Einstein had his own approach based on more particular physical things, and Hilbert had his variational approach and so on. So the fact that Klein adds a note to say, I think that Einstein and Hilbert should not be considered as being in the competition, this is precisely a sign of the fact that actually there was someone, or maybe themselves or someone else, who was considering them to be in competition. So the debate was already there at the time. And in this sense, we cannot say that, okay, maybe special relativity is now more debated, the authorship of special relativity, but at the time it was general relativity which was more debated. There was the story about Young-Mills theory. There might have been some story about quantum mechanics and so on. So we are just focused now on that particular story of special relativity, but there are more stories with every theory we have. So yeah, Gingras' reply is simply that why special relativity debate became so popular, because there were commemorations, particularly in 2005, the 100 years of special relativity, and that somehow triggered the debate. And you should also see that all these authors, so Daigo, Gingras, Genoux, they are French or French speaking. So of course they're interested in the contribution of Poincaré, who was the French. But the Einstein-Hilbert debate, okay, we can say Einstein is a Jewish, but still Einstein is German-speaking, Hilbert is also German-speaking. So from this point of view, this would be an internal debate between Germans, where the one German-speaking person was also another German-speaking author. It's not as interesting as to say the person from my country was the author and the person from another. So maybe there is this kind of sociological reasons influence. Yeah, thank you.
Thank you so much. I agree.
Are there other questions from participants? No? Okay, if not, then we thank our speaker again. Thank you, Valeriya. It was very interesting and stimulating, and yeah, I hope to see you all soon. And
Yeah.
thank
Maybe
you.
Sylvia, just yeah, thank you for this opportunity. I would like to maybe just say so yeah, you are recording this. Well, I don't know whether you need to record
Okay,
what
so I'm
yeah,
stopping the
yeah.
recording. Okay.
It's not a secret thing. Yeah.